start. Inverse of Laplace transform. What is the basic definition? Let's write down the definition. If Laplace transform of f of t equal to f of s, then there exists a function such that f of t equal to L inverse f of s, then f of t is said to be inverse of Laplace transform. Okay, so in the first method, finding the inverse of Laplace transform. So we know that Laplace transform of sin t is what? 1 by s square plus 1. So here, so sin t equal to, we can write it L inverse s square plus 1. That is L inverse f of s. So here f of t. So we can say that the inverse of s square plus 1 is equal to sin t, which is the inverse of Laplace transform. So this is the basic definition, and all of the roots of this chapter. So here is cos t. Laplace transform of cos t is what? S upon s square plus 1. So L inverse s square plus 1 is equal to cos t. So cos t is the inverse of Laplace transform of s square plus s. When we find a function such that s square plus 1 is by 1, that is the, we'll say that this is the inverse of Laplace transform what? Cos t. So that is the definition, we have understand it. Now we are moving to the large theorem. Next topic. If I have write down it, let's go into the next topic. Now what is the null function? If Laplace transform of f of t equal to f of s, okay, then there exists a function such that integration 0 to t f of s ds equal to 0, then f of t is said to be null function. Okay, that is the null function. Now we have seen the definition of inverse of Laplace transform and the null function. We will see the write down the next topic. Have you understand? So this is the definition. You can easily find it which is the null function or not. Now third, there is the large theorem. What is the large theorem? If Laplace transform of f of t equal to f of s, so the n ft and null function it is denoted by null nt. Okay, if nt is the null function, then there exists a function such that Laplace transform of f of t plus f of nt equal to f of s. That is the large theorem. So that is the large theorem we have understand. So if you can prove it, ft is Laplace equal to e3t. Okay, Laplace transform of e3t is what? S minus 3. Okay, now so let nt is equal to denoted by t greater than equal to 0 or e minus e3t otherwise. Okay, so you can find that Laplace transform of f of t plus nt equal to Laplace transform of f of s. That is the last theorem, you can prove it. So here, so let's proceed our next result on Laplace transform. Okay, have you written down it? So we are moving to the next topic of our Laplace transform. Standard result of some standard result of inverse of Laplace transform. Write down it. So we are here. Now we are finding the inverse of Laplace transform. We know that first Laplace transform of Tn equal to what? Comma n plus 1 upon Sn plus 1. When here n is not integer. So inverse of, write down the inverse of comma n plus 1 upon Sn plus 1 is what? Tn. That is like a function that we have seen the differentiation and integration. If d by dt and cos t equal to what? Sin t. Okay, so integration sin t is equal to minus sin t, dt is equal to minus cos t. That is the inverse of, that is like that. So next we are, when Laplace transform of Tn equal to n factorial upon Sn plus 1. So inverse of Laplace s n factorial upon Sn plus 1 is equal to Tn. So here n is integer. Okay, so third, Laplace transform of cos at t is equal to what? S upon s square plus s square. So inverse of s upon s square plus a square equal to cos at t. Fourth, Laplace transform of sin at t is what? 1 upon s square plus s square. So inverse of 1 upon s square plus s square equal to sin at t. So that is the some standard result we have seen in the preceding chapter, what we have learned. So here we have seen the some result. Now we are moving to the further result of a Laplace, inverse of a Laplace transform. Okay, so have you written? Okay. Oh my god. So Laplace transform of sine hyperbolic at t is what? We know s upon s square minus s square. Okay, so inverse of s upon s square minus s square equal to sine at t. Fifth, write down it. Sixth, Laplace transform of cos hyperbolic at t is, sorry, yeah, this is will be 1, will be s upon s square minus s square. So inverse of s upon s square minus s square equal to cos hyperbolic at t. Okay. 7. Laplace transform of E3 E at t is what? That is equal to S plus A. Okay. So inverse of 1 plus S plus A is what? E at t. Write down the next 8. So that is a Laplace transform of I have write down the major of the topic that we have covered in the preceding chapter of inverse Laplace transform of a function. Now if I have left something that you can write down it and in your note paper. So now that is the basic introduction of Laplace transform of a function. Now we are moving to look at the property of a inverse of a Laplace transform of a function. So if you have write down it, I am erasing it so that I can move forward. So write down the properties of Laplace transform. Properties of Laplace transform. Sorry, properties of inverse of Laplace transform. First, linearity property. Okay, if Laplace transform of f of t is what? F of s. So inverse of a Laplace transform of f of s is equal to what? F of t. So that is our first if. So if then inverse of Laplace transform c f of a1 s plus c f of s2 equal to, that is the inverse of Laplace transform of f of 1s plus c2 Laplace transform of f of 2s2. That is the result that you can prove it. Now that is your result, that is on you. You can prove it. Now I am not going to it how to prove it. So that is the basic result, you can prove it easily. So that is not matter how to prove it. Now next we are moving to do the example of Laplace transform, inverse of a Laplace transform. So what we have seen, now write down, find the inverse of 1 plus s5. Okay, so I think s5. We have a function, we have to find out, write down the question, find the inverse of the Laplace transform of the following function, Laplace transform. So here ls5 4 what we have, so we can write it inverse of s3 plus 1. So that is, we can write it tn upon what? 3 factorial, that is t3 t cube upon 6. Because what we know, if Laplace transform of tn is equal to that, where 4 is an integer, so we can write it n factorial upon sn plus 1. So that is our result. Based on this we can prove it. Here we have, there is no 4 like that. If instead of this we have a question, Laplace 6 upon s4. Okay, so we can write it Laplace transform of 6 s3 plus 1. So that give us what? Here 3 factorial, so which will give us 3 factorial 3. So that is Laplace transform of t. So ft is what? Ft is equal to 3 cube. So based on this you can prove it. Now we are going to move in the further question 2. Find the inverse of s upon 2. Can you find it? Yeah, obviously you can find it. Here you can see it that we can find it as 1 by 2. 1 by 2 is not a integer, so it is a fraction. Obviously we can use the formula gamma n 1 plus 2 plus 1 upon s. Instead of s we have a here that is can be written as so we know that gamma Laplace transform of t n equal to what? Gamma n plus 1 upon Sn plus 1. Okay. So here we can write it Sn plus 1. Okay. Sn. So here we have a function. So look at the board. F of tn equal to gamma n plus 1 upon Sn plus 1. So inverse of tn. Okay. Tn upon gamma n plus 1 equal to Laplace transform of Sn plus 1. That is our f of s. That is not come under this. So that is the inverse of this function will be this. So we will use it. So what we get? Now here we have inverse of s 1 plus minus 2 equal to t half minus 1. So that give us one by gamma root pi upon t. So that is the result. I think you have got it how to find a Laplace transform. The question that I have left will move in further, so that the concept will be the crystal clear. So do like, share, subscribe, follow me. Thank you for watching me.